Hello, this is Mr. Martin. This is a video solution for number 3 from the notes packet in section 8.4 on inductive proofs. So we've got the relationship 1/2 plus 1/4 plus 1/8 all the way up to 1 over 2 to the n. That sum can actually be found by 2 to the n minus 1 over 2 to the n. So we're going to again use inductive proof to prove that. So step 1, we want to show it's true for k equals 1. So we plug 1 into this last generic term and we get 1 over 2 to the first. And then we don't know if it's equal yet, so we put our equal sign. And then we plug in 1 to the expression on the right, and we get 2 to the first minus 1 over 2 to the first. And we do in fact get that the two sides are both equal to 1/2. So it's true for k equals 1. I've mentioned this several times, but make sure you don't forget these first two steps. It's an important part of an inductive proof, the structure of it. All right, then number 2, we're going to assume that S sub k is true, and then we're going to prove it true for S sub k plus 1. So we're going to assume that the sum up through some value k is true. Then we're going to prove it true if we add one more term. So don't forget this part here. It's important to start with the original series here. And notice I've substituted in k because we're going to assume it's true up to k. And then we're going to add one more term for k plus 1, the k plus 1th term. And we want to show that it's equal to the sum for the k plus 1th term. So S sub k is going to be this term with k substituted in. So that's 2 to the k minus 1 over 2 to the k plus, and then this last term that we added. We want to show it's equal. And then the last part here is just going to be algebra. So what we want to do is get that in the screen for you. Let's do that. There we go. We're going to multiply, let's try that again. Multiply both sides by 2 to get a common denominator, and I'll show you how that works. So I'm just multiplying this fraction by 2 over 2. All right, and then everything else here is the same. And then moving over here, if I distribute this 2 in the numerator, I have 2, which is really 2 to the first, times 2 to the k, and then 2 times negative 1 minus 2. And then the denominator, I have 2 times 2 to the k, and then plus our other term. Now, 2 to the first times 2 to the k is 2 to the k plus 1. So all of this is equal to that. Remember, when we multiply numbers with the same base, we add their exponents. All right, and then we do the same thing in the denominator. So this 2 to the first times 2 to the k is 2 to the k plus 1. And now I can add these two fractions because they have a common denominator. So I just add their numerator. So I have 2 to the k plus 1 minus 2 plus 1 over 2 to the k plus 1. And then our final step would be just to combine my like terms. Minus 2 plus 1 is going to be minus 1. So 2 to the k plus 1 minus 1 over 2 to the k is in fact equal to 2 to the k plus 1 minus 1 over 2 to the k plus 1. All right, if you have questions, let me know. We'll see you next time.